I am the virtual teacher at Egnatia Career College. Today we'll teach determining the number and location of lighting and receptacle branch circuits. This is video number 3. Determining the number and location of lighting and receptacle branch circuits. After studying this unit, you should be able to determine the number and location of lighting outlets in a dwelling unit. Determine the minimum number of and location of receptacles required in a dwelling unit. Identify CEC requirements for lighting and receptacle branch circuits. In the design and planning of dwelling units, it is standard practice to permit the electrician to plan the circuits. Thus, most residence plans do not include layouts for the various branch circuits. The electrician may follow the general guidelines established by the architect. However, all wiring systems must conform to the standards of the Canadian Electrical Code, CEC, and the National Building Code of Canada, NBC, as well as local and provincial requirements. This unit focuses on lighting branch circuits and small appliance circuits. The circuits supplying the electric range, oven, clothes dryer, and other specific circuitry not considered to be a lighting branch circuit or a small appliance circuit are covered later in this text. Lighting. In this unit, we look at where lighting fixtures and receptacles must be located to meet the minimum requirements of the CEC. Lighting fixtures, luminaires, lamps, and ballasts will be covered in Unit 10. The CEC has adopted these requirements, which are found in Rules 30-500 through 30-510. The provisions for supplying a light fixture in a room or area and whether it is to be controlled by a wall switch are found in Part 9 of the National Building Code of Canada. The CEC has adopted these requirements, which are found in Rules 30-500 through 30-510. Outlines these requirements for lighting in dwelling units. This figure 4.1 shows them graphically. Receptacles. Receptacles are required in dwelling units and must be tamper-resistant, Rule 26-706, and in most cases must have arc fault protection, Rule 26-656. Receptacles are used for the connection of large and small appliances. Receptacles installed for small appliances are 15 ampere, 125 volt. 1 pole, 2 wire, or 2 pole, 3 wire. Or 20 ampere, T-slot, 125 volt, 1 pole, 2 wire. Some residences are lighted by table and floor lamps plugged into switch-controlled wall receptacle outlets. In bedrooms and living rooms, switch-controlled wall receptacles are permitted in lieu of ceiling and/or wall lighting outlets. Only half of the receptacle may be switched if the receptacle is needed to satisfy the minimum number of receptacles required by Rule 26-724A. This is achieved by removing the tab on the hot side of the receptacle. This unit will identify the locations where the CEC requires 15 ampere, 125 volt, 5-15R, and 20 ampere, 125 volt, 5-20R receptacles. In this figure you can see split-switched receptacle wiring diagram. In this figure you can see split-wired receptacle, split receptacle, on a 2-pole 15 ampere breaker connected to a 3-wire circuit for use in a kitchen. This table shows the minimum number of receptacles required in a dwelling unit and their locations. This figure shows locating receptacles on the first floor. This figure shows locating receptacles in the kitchen, laundry room, and garage. This figure shows locating receptacles in the basement. Basics of wire sizing and loading. The CEC defines a branch circuit as that portion of the wiring installation between the final overcurrent device protecting the circuit and the outlets. The CEC defines a feeder as the circuit conductors between the service equipment and the final branch circuit overcurrent device. In the residence used as an example in this text, the wiring between panel A and panel B is a feeder. The ampacity, current carrying capacity, of a conductor must not be less than the rating of the overcurrent device protecting that conductor. The rating of the branch circuit is determined by the lesser of the rating of either the overcurrent device or the ampacity of the wire. For example, if a 20 ampere conductor is protected by a 15 ampere fuse, then the circuit is a 15 ampere branch circuit. The ampacity of branch circuit conductors must not be less than the maximum load to be served. Where the circuit supplies receptacle outlets, as is typical in houses, the conductor's ampacity must be rated to carry the load. The load current must not exceed 80% of the rating of the overcurrent device for that circuit. Where the ampacity of the conductor does not match up with a standard rating of a fuse or breaker, the next higher standard size of overcurrent device may be used, provided the overcurrent device does not exceed 800 amperes. This exception is not applicable to residential branch circuits because the standard overcurrent device sizes listed in CEC Table 13 correspond directly with the ampacities listed in Table 2 for number 14. And number 12 gauge wire, Rule 14-104, 2. Table 13 shows that the maximum overcurrent protection is 15 amperes when number 14 AWG copper wire is used. Residential branch circuits are fed from panel boards having overcurrent devices that are rated to be run continuously at a maximum of 80% of their ampere rating. The conductors attached to these overcurrent devices may not be loaded to more than 80% of the ampere rating listed in Table 2. For example, a 15 ampere circuit breaker has a maximum load of 12 amperes, 15 amperes times 0.8. Therefore, the wire must be rated for 15 amperes in Table 2, a number 14 or 90XLP is suitable. The ampacities of conductors commonly used in residential occupancies are listed in Table 2. These are subject to correction factors, which must be applied where there are high ambient temperatures. For example, in attics. See Note 1 to Table 5A. Conductor ampacities are also derated when 4 or more conductors are installed in a single raceway or cable. See CEC Table 5C. In this residence, all lighting circuits are rated at 15 amperes. The maximum loading of these circuits is 12 amperes. Note that the CEC provides the minimum number of branch circuits required. For various purposes, you may install more. Load calculations for electric water heaters, ranges, motors, electric heat, and other specific loads are in addition to the general lighting load, and are discussed throughout this text as they appear. Voltage. All calculations throughout this text use voltages of 120 volts and 240 volts. CEC Rule 8-100, entitled Current Calculations, states that the voltage divisors to use shall be 120, 208, and 240, as applicable. This voltage is used for calculation even though the actual voltage may be 220, 245, or 247. This provides us with uniformity to avoid misleading and confusing results in our computations. Lighting branch circuits. The CEC limits overcurrent protection for lighting branch circuits to a maximum of 15 amperes in dwelling units, Rule 30-104. When a branch circuit is loaded, it will normally have a maximum of 12 outlets, Rule 8-304. If the actual load on the circuit is known, the number of lighting outlets may be increased as long as the load on the circuit does not exceed 80% of the rating of the circuit breaker or fuse protecting the branch circuit. It is normally impossible to tell what the actual load of each lighting fixture on a branch circuit is when doing the rough-in, unless a large number of recessed luminaires are installed. Therefore, the maximum number of outlets on a lighting branch circuit is 12. When you install track lighting with movable fixtures, the authors recommend that you count every 600 mm as one outlet. Receptacle branch circuits. Branch circuits in dwelling units can consist of lighting only, receptacles only, or a combination of lighting and receptacles. When a circuit consists of a combination of lighting and receptacles, the protection for the circuit is limited to 15 amperes, the same as it would be if the circuit had lighting only. When a circuit contains receptacles only, the protection for the circuit cannot exceed the rating of receptacles for general applications in dwelling units. Convenience receptacles may be CSA configuration 5-15R or 5-20R. Preparing a lighting and receptacle layout. One blank full-size drawing of the floor plan is provided with this textbook to allow you to design and prepare your own electrical layout. Begin by using Table 4.1 to identify where luminaires are required. Locate the luminaires on the floor plan. Add any extra luminaires, such as in closets, that you feel enhance the design. Just remember that the lowest bid will normally get the job. Determine where you would like to locate the switches controlling the luminaires. Write S on the floor plan if you want to control the luminaires in a room from one location. Write S3 on the floor plan if you want to control the lights from 2 locations. If you want to control the luminaires from more than 2 locations, see Unit 6. Use Table 4.2 to determine the location of receptacles required by the CEC and locate them on the floor plans. Use figures 4.6 through 4.8 to assist you. Add any extra receptacles that you feel enhance the design. When you have completed the layout of lighting and receptacle outlets, group the outlets into circuits. In general, 12 outlets are permitted on a circuit. There can be a mixture of lights and receptacles in most cases. Use Table 4.3 and figures 4.10 through 4.12 to help you. Further information about additional loads that will be added to the layout are found in later units.